Today we are going to discuss about some concepts in SQL and MongoDB, right? In SQL, we are going to discuss about joins, views, triggers, and indexes, right? And in MongoDB, we are going to discuss about sharding and replication. Got it? This is one thing. So yeah, now let us get into the concepts, guys. Coming to the joins, right? There are four kinds of joins in SQL: inner join, left join, right join, outer join. So these are the four different joins in SQL. And what are we going to do with these joins? Let us discuss that. So in SQL, what we have, guys? Tables, and we have different tables, not a single table, right? And there are some scenarios we want table data from these both tables on certain conditions, right? And we have to ignore some rows from one table and take some rows from another table. So for these separate execution of scenarios, we use joins, right? Now first let us get into the inner join, and let us take an example table. And here also let us take another example table. Oh, shit. So in the first table there is course ID, roll number 1, 2, 3, 4, 5. And in the second table also there are two things, one is roll number and another one is name. So again 5 rows, 1, 2, 3, 4, 5, 1, 2, 3, 7, 8, and 1, 2, 3, 4, 5. Names are A, B, C, D, E. So now we want the data where let us say we want the data where the roll numbers are equal. So the roll numbers which are equal are 1, 2, 3. So we will write a query like select roll number, name, and CID from both tables, which is, let us say this table is S, this table is C. S dot roll number, S dot name, and C dot CID from table S, join table C where roll number C dot roll number equal to S dot roll number. So now we'll get a table something like this: RL CID name 1, 2, 3, 1, 2, 3, ABC. So in a Venn diagram perspective, which is like this is the table A and this is the table B, and these are the equal things they got. So this is called inner join, guys. So now let's come into the next thing, which is left join. So first let us discuss the Venn diagram of it. A table, B table, and we will get these things. So this is called left join. So here also, instead of inner join or join, we will do left join on the same statement. So we'll get a combination table of this, where we get again 3 rows, roll number, CID and name, but we get 1, 2, 3 and 4, 5 rows also, because we are doing left joins and we will get all the rows in the left thing. So 1, 2, 3, 4, 5 and 1, 2, 3 A, B, C, and as these roll numbers are not there in the RN of the second table, we will get null values here. Got it? So this is called left join. Now let us come and discuss right join. So right join is just opposite of the left join, right? So now let us take, yeah. So with the same statement, but we will do right join. So with the same thing, we'll get another table. One is RN, name, CN. So again, we'll get 5 rows, 3, 4, and 5th row. So here, what we'll get is, instead of the right table all values, we'll get the, sorry, instead of the left table all values, we'll get the right table all values. 1, 2, 3, 4, 5, 1, 2, 3, and A, B, C. Here we get again null values. Null, 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 null. Got it? So this is called right join, and in the Venn diagram presentation, A, B, yeah. So the right table totally we will get it, and the other things we don't have, will have, sorry, here also we'll get 7 and 8. We will have null values, right? Now let us go to the next thing, which is outer join, which is just the combination of left and right joins. We will get all rows and all columns, but what we'll get is null values wherever the join is not present, right? So we'll get a very long table, 3 rows, sorry, 3 columns again, RN, CN and name. So we'll get A, B, C, D, E, which is just the combination of left and right, but still, so wherever we do not have it, we'll get none. So here we have 1, 2, 3, null, null, 7, 8, null, and null. Right? So we have got all the combination of rows here. So this is called outer join, and we have, sorry, we have discussed this is the representation of outer join. So guys, these are the different types of joins in SQL. Now let us get into the next concept called views. Okay, what are views? So views are just temporary tables which are created. So let us say now you want to get all the left join rows as we have before. So you'll write the statement and create a view on it. So this will be stored as a query somewhere. So instead of typing or writing the query again and again, you will just call this view. So let us say this view name is left join view, right? So now you will just call select star from left join view semicolon. So instead of writing the view or the BigQuery every time, you will just call this thing and the same thing will be executed time and the real time data you will be getting. So this is called view. There will be another type of view called materialized view in some tables only, like Postgres and Amazon RDS, Redshift DB. So what this materialized view is, instead of saving the virtual query, it will save the real data and it will consume the real storage. So let us say we will execute that left join query every time when we call this view. But here we will not execute the query. It will instead create the table, right? RN name and yeah, CID. So instead it will create the table and it refreshes the table whenever we call the view and returns the data or returns this table. So this is the difference between the normal view and the materialized view. Got it? These are about the views. Now coming to the next things, which are indexes, right? So what are indexes? Why are they used? So remember, in a book we have about 140 to 180 pages, and you want to go to a certain chapter number 4 or something. So you have to go through all the pages, right? From 1 to, let us say, 40 pages. The chapter 4 is at 40 pages. So you have to go through 1 to 40 pages by revising. You don't know at which page the chapter number 4 is. So you have to turn over the all pages. So instead, now what you can do is you can keep an index. Sorry, you can keep an index at the starting page 1, 2, 3, 4, 5, and it is at the 10th page, 20 page, 30 page, 40 page, and 50th page. So you will see the chapter number 4 and you will go to the 40th page immediately. So what this will save us is the time, right? So in a book we don't append data every time. It is the data will not change, right? We will only read the book. But in a table we will also append the data. The data will be appending and changing every time, and we will also read the data. So that's why these indexes are different. So now what we will do is, let us say we have data in table and their data is split into like pages or something, which is a similar thing. So now the particular rows, right? Let us say the first 100 rows, next 100 rows, and the next 100 rows. So now let us say you have created index for these things, and these are about normal users, premium users, and pro users. Okay, these are the different rows. So now instead of parsing the all rows, whenever you have this norm, let us say you want to search the pro user, you have to now go through all these rows and find the pro user here on some condition. So what indexing will do is, now these are the first 100 rows, and these are the second 100 rows, and these are the third 100 rows. Now we will have a pointers. Let us say you index that column, and whenever there is individual, you can directly come to this and search here, and whenever there is premium, you can directly come to this and search here, and whenever there is pro, you can directly come to this and search here. So you can save the time. But whenever you are appending the data, after updating the table and stuff, you have to update this index pointer. Let us say you have appended 10 new individual users. Now you have to insert in this table and you have to update the index to this length also, from 100 to 110. So this makes the writing more complex, but reading operations more simple. So you can create indexes on certain columns, etc. So there will be good reading, and the return time of the rows and stuff will be faster, right? This is called indexing, guys. Now at last, the last concept in SQL is triggers. So triggers are something, a set of SQL functions, SQL statements which execute when needed, right? So this needing can be triggered through a event. Let us say you have a log table and you have a normal table T. So whenever there is a change in this table, you want to update the timing and the change in the T table to the log table. So this is an event which is update, right? So you'll write an SQL function, SQL trigger, which states that update the time, uh, create a row in the log table with some timestamp. So this trigger will be executed whenever there is an update in T table. So by that we will get the logs of the table. So where are we using these triggers? So let us say some new intern came and there is a DB T table and he is updating the rows in this table. From somehow he has updated some 40 rows in this table, which leads to the corruption of this table. So when we can know the log, and if we have a backup before, we can revert to the backup time before the timestamp in this log table. So in this way triggers are useful, right? Yeah. So we have discussed the joins, different types of joins, views, triggers and indexes in SQL. Now let us come to the MongoDB, guys. In MongoDB, now we are going to discuss two things: replication and sharding. Right? These are the two things we are going to discuss now. So the first thing, what is replication? So let us say we have a DB server 1. Now suddenly some disaster came in the server location. Let us say this is some Bangalore or Hyderabad, and some disaster came at these locations and this DB is crashed. Now we don't have a way to refer to this data because there is no backup. So what we can do is, before something like this happens, we can keep a replica of this such that we have more availability when something like this happens. So there is this master slave system in MongoDB where this is the master DB which is in one location, and there will be more slave DBs in another 3 locations, right? 1, 2 and 3. So this acts as a master and these acts as a slaves, right? So now what will happen is, this will write the data, which is, so whenever we want to write data we will use this DB, and this DB in background writes the data into the 3 DBs. So, and this can be used for the more availability also. Let us say your location is nearer to this DB. Now when you are accessing the data, instead of reading from this DB, you can read from this DB, which makes the latency very lesser, so you can access the data. And in background this will write the data to the replica sets, so the data will be consistent. So this is a we can implement this using simple commands in MongoDB, and rest of it is taken by the master slave system in MongoDB. So this is a very simple concept which will give us more availability, less latency, and good disaster responses. So we can back up the databases easily, etc. So this is about replication, right? Now at last we come to the concept called sharding. So now again we have some, let us assume we have some collections called C1, C2 and C3. C1, C2, C3, and we are storing in a single DB. So this is also causing a lot of storage in this DB and also a lot of latency. Let us say you have to search something through all these three collections. You have to go through this, etc. Might be like something like that, not particularly this, but yeah. And this volume will be increasing, and it's hard to search something through a very large database. So now instead, you will divide the data and put shards. We'll divide the data into shards, right? So now let us say this is the collection one, and we have 3 DB servers. DB1, DB2, DB3, and we have something called shard keys, right? Now we will divide some of the data into chunks and store in this thing and in this thing and this thing, and they are assigned with shard keys. So whenever user is retrieving something, if that is in the first chunk, we will go to this and retrieve this using the shard key and return to the user. Again the same thing, and yeah, we will do the same thing. And the one which helps us to do this thing is inbuilt query router in the MongoDB. So guys, these are the concepts we have discussed today, right? So the first thing is, in SQL we have discussed joins, and in joins there are 4 joins which are left, right, inner, outer, and views, triggers, and at last indexes, right? And in the MongoDB we have discussed sharding and collections. So now let us get into the VS Code and see these things in implementation, how these are done. So this is the README file I have written to refer all these concepts, guys. You can refer this, right? Now let us go to the phase file, and I have kept two folders here. One is Postgres and another one is MongoDB, right? Now I have created 2 Docker Compose containers so that we can practice them in this here. So let me clear this. Now first we have to log in into the Postgres container, guys. So let me log in. Right. Now let us execute the things in Postgres. This is here. This is the schema. I think I have pasted something wrong. Create table order items. Where is it? Yeah. So let me take this out. Why is this taking this much time, guys? Let me do one thing. Exit, exit, click Ctrl, copy this again and paste it and execute. So yeah, so as we can see here, we got create table 4 times, create index 2 times, create view, create table, and create function and trigger, right? So we have created a user table, products table, orders table, and orders items table, and we have created indexes on 2 things. One is IDX user email, IDX order table. So whenever we query using these emails and you want to find something on event email, it will be faster, right? And this is the view, right? So now, and this is the audit table which logs everything, and this is the trigger which we are talking about, log stock exchange, such that it will edit the contents into the audit log table, which is this, right? And this is the trigger which will be executed when we update the stock on products table, right? So now let us get into this stuff and do all this. Control L, execute. So now we have executed this, started a transaction, finished it, and now let us see this. Selected. 1 minute, I forgot the table name. Select star from audit log. Right, so there is a one row, guys, and remember, if we update something in products table, it will get updated. So let us find the command, let us find the query which updated the stocks table here. Yeah, here now we are going to do this again, where id equal to 1. So now let us do 1 here. So now let us query the log table again. As we can see, we have two tables, two rows now. So here the old stock is 10, the new stock is 8, the old stock is 8, and the new stock is 7, because we reduced one thing. Let us do this again, and let us, yeah. So as we can see, the trigger is triggered now because of the update event in the products table, and we have changed the stock. Now we are logging that into this table, right? Now, and let me search what are the things, indexes. Let me search here the Postgres. So let us copy this command and see the indexes. As we have now three indexes here. One is PGAM name index, 0 AID index. Oh, sorry, there are so many indexes here. To find the indexes, yeah. So now we have the primary key indexes in every one, and the two indexes which we have created are, one is IDX order update, yeah, and IDX user email. As we can see, the index are created here, and the storage which is taken here is 16 KB, and this is a B-tree type of index. So guys, here's that's how we can list the indexes and we can see them. Now at last, let us take the view. Select star from order summary. So now we have 0 rows because there is no ID equivalent stuff. So now instead of executing this every time, we can just call this view which execute this automatically. So this is how a view work, guys, right? So yeah, we have seen the triggers, views, and joins also, but still we haven't had the sufficient data to execute these joins, but still, yeah. And also we have seen how a audit log table works, and when the update event is triggered, we can append the data into the table, right? So this is one thing. So now let us exit from this, clear the console. Now it's time to log into the MongoDB. In MongoDB, there is no execution stuff, guys, because I need to deploy about 2 to 3 servers to add the DB as a replicate. That's why I wasn't able to do it. But still, here we have the query in the schema format, and you can log in into it. Give me 1 minute. Shit, I think I have executed some MongoDB, so that is not the matter now. Okay, guys, this is backup, restore, root password. I forgot how to log in, guys. 1 minute. Yeah. Yeah, here we are. Now let us do show DBs. We have only 3 DBs, so now execute this MongoDB, schema.js and queries.js. Shit, I think I have to execute it separately, guys. So now we have a test DB, use test, okay, show collections. Yeah, now we have 3 things. Okay, until this is executed, what is the command for indexes? Let us search db.collection.get indexes. Let us do that. db.test.get indexes. Um, okay, sorry. db.orders.get indexes. So now we have index on ID, right? Now again do the same thing for the users. db.users.get indexes. Same thing. We have the index on ID. Now let us do the same thing for the products. Let us see if there is another index or not. No, there is not another index. So let us create this. So as we can see now, there is another index, right? So these are just common commands, guys. You can go through it, and we have used some functions aggregations in MongoDB, such as this increment, which will do the incrementation of -2 on the stocks, and these are just delete one find operations. And here we can see some multiply, some of the aggregation operations, and there are another aggregation operations which are mostly used in MongoDB, which are these, which are match, such as where in SQL, group like group by in SQL, sort for sorting the documents like 0 and 1, such that you can sort in ascending and descending order and stuff, limit to limit the documents, etc. So these are the different types of aggregations in MongoDB. Um, this cannot be explained in a video, guys, so we have to take a separate use case or use statement for this, and then start executing this. So yeah, so this is the phase 5, guys. As we have already seen, now we have gone through all the concepts which are mentioned in this phase 5.mt. So again, let us go through it, and if there are anything missed, let us go through it also. Joins we have gone through, as we have discussed about the views, indexing, and guys, go through this. If search through the internet what are the b-tree, hash, gin, gist, so such that we can get more context on the indexes, right? That takes a more in-depth explanation. And these are the different types of indexes in MongoDB, right? So yeah, that's it, guys, for the this video. In this video, we have gone through different concepts, and in the next phases, we'll go through a simple real-time project in SQL and MongoDB. And after that, we'll see some different types of DBs like time series DB, cache DBs in real projects. So, what are the use cases for it? What are the other DBs we should consider using, etc. So, yeah, that's it. And yes, let's end this video. Thank you, guys.